Right now, somewhere inside your skull, there may be a perfectly good memory of your first birthday. You simply cannot open the file. For your entire life, you assumed those years were never recorded. The cake, the first steps, the face leaning over your crib, all of it gone, you thought, because a baby brain is simply too unfinished to write anything down at all. But a scanner full of wriggling babies recently suggested something far stranger, and it quietly changes what forgetting even means. The memories might still be inside you right now. Every one of them, sitting exactly where you left them, perfectly intact. Something in your own brain locked that door, and then, very helpfully, went ahead and threw away the only key. Scientists have a name for the blank spot at the very start of your life. They call it infantile amnesia. And here is the first clue that this is not simply ordinary forgetting, the kind that erodes any distant memory. Ask a college student for their earliest memory, then ask their grandmother. Both of them land at about age 4. 60 additional years of forgetting does not push the grandmother's line back any further. The wall sits in the same place. So, something specific happens before age 4, and the suspicion points straight at one small structure buried deep inside you. It is shaped like a seahorse, and it is called the hippocampus. It writes down the memory of a specific moment. We know this from two people who lost theirs. Henry Molezan and Lonnie Sue Johnson suffered hippocampus damage as adults. They could still learn new skills, but they could no longer hold on to a single new event in their lives. They were living, in a sense, the way a baby remembers, which raised an obvious suspicion. Maybe the baby seahorse is unfinished. To test that, you would have to look inside a baby's brain at the exact moment it tries to remember something, which sounds impossible. In 2025, a Yale team led by Tristan Yates and Nick Turk Brown went ahead and did it. They slid 26 wide-awake infants, aged from 4 months to 2 years old, into a magnetic resonance brain scanner. Keeping one single wriggling baby perfectly still inside a giant humming magnet is, on its own, a small scientific miracle. Each baby quietly watched a stream of unfamiliar faces, objects, and scenes flow past them, one after another after another. Later, those very same images came back, shuffled in among brand new ones that the baby had never seen before. Now, a baby obviously cannot tell you what it remembers, but babies do one single thing that is completely reliable. They stare much longer at whatever they recognize. So looking time became the readout. The stare itself was the confession. And the scanner caught the moment of recording. The harder a baby's hippocampus lit up, the longer that baby later stared. The seahorse was working. Around 12 months old, babies were encoding real specific events in the exact region adults use. The old theory broke. Their brains were recording all along. So if the tape exists, where on earth does it go? The answer may be that a baby's brain is a frantic building site that never stops renovating itself, day and night. Your hippocampus keeps manufacturing brand new neurons for your entire life. In infancy, it manufactures them in an absolute flood. And every single new neuron wires itself into the existing circuit, elbowing all of the older connections roughly out of place. Picture a memory as one specific path through a wired maze. Now rebuild that maze daily while the memory sits inside it. The path is not deleted, exactly. It gets buried under new construction until nobody can find the way back in. Scientists actually watched this happen. In mice, they put adult mice in a striped room that smelled strongly of vinegar. They gave them one mild shock. 28 days later, those adult mice still froze in fear at that same room. Baby mice forgot the identical room within a single day. Same shock, same stripes, same smell of vinegar. Gone by morning. Then came the genuinely strange part. Researchers took adult mice and cranked their neuron production back up using simple running wheel. The adults began forgetting the scary room too. More new neurons. Less memory. Exercise was quietly erasing their own past. And running the trick backwards sealed it. Scientists slowed neuron birth in baby mice, roughly cutting the flood in half. Those babies suddenly held the fear memory for a week instead of a day. The flood itself was the eraser. So here is where it lands. The baby memories were never blank tape at all. They were recorded, then buried. Buried under the frantic wiring of a brain that was busy becoming yours. And buried is not the same as gone. In a follow-up experiment, scientists used precise pulses of light to switch specific mouse brain cells back on again. And a lost infant memory flickered back to life. The file was still there. It only needed the right key. Turk Brown suspects the very same thing is true of you, sitting there, right now, unable to remember your own beginning. As your brain rebuilt itself over and over, you lost the cues that once pointed the way toward those earliest scenes. The memory of your first birthday may be sitting in your hippocampus this very second, entirely intact and completely unreachable. Waiting behind a doorway that no longer exists, because you tore it down yourself while you were learning how to walk. You are not missing those years because nothing happened. You are missing them because you grew a better brain on top. And somewhere underneath all of that construction, a 1-year-old is still sitting there, quietly staring at a cake.